Test 1, 2. All right, well, hello everyone. Welcome back from lunch on our first day of the workshop. My name is Richard Evans. I work here at the Armstrong Test Facility. And the talk I'm going to give today is a very high-level, user-oriented talk. This is my justification to the folks in my world about why MediaWiki is particularly suited for solving a problem that we've been trying to solve for many years, and the recent combination of new extensions in the community combined with upgrades in the MediaWiki core are finally allowing us to move forward on something that's been on our to-do list for 10 years, which is quality work instructions at NASA using MediaWiki Plus. For the outline, I'm going to tell you a little bit about what I mean by MediaWiki Plus. I'm going to tell you a little bit about NASA, the Armstrong Test Facility. I'll breeze through those things because I think we've already touched on them pretty well. More importantly, what we mean by, within NASA, what we mean by quality management systems, and then what we mean by work instructions, and then you'll be in, and then we'll do a real-world example. And then we'll talk about what the actual aerospace requirements are for quality work instructions. I'll tell you a little bit how the current process is still paper-based and what our plans are for digitally transforming that paper process into a wikified solution. And then I'll wrap up with what we've done so far and where we're at. From when I talk about MediaWiki Plus, I know if you guys have ever heard me give a talk before, this is my mantra, is that MediaWiki Core is wiki software par excellence. And the community, all of us, and so many others that build, develop, and maintain these third-party extensions that allow MediaWiki Core to do hundreds of other things that it was not originally designed to do. And when you think of MediaWiki, the plus is the plus all of the third-party extensions. And so MediaWiki Plus results in the logo that you see on the far right, where we've taken wiki software par excellence and we've turbocharged it with third-party extensions to allow it to transcend its classification. Its MediaWiki Plus is no longer merely wiki software. It becomes almost a universal platform for doing database application implementations. A little bit about NASA. Most people recognize the NASA name. Not everyone is familiar with where you would go around the United States in order to find a NASA facility. So on the screen is a map of the United States. The dots represent different places where NASA has a physical presence. Our workforce is a little bit less than 8,000 federal employees, tens of thousands of support service contracts, and distributed around 10 field centers, 7 support facilities, of which Armstrong Test Facility is one. And I recently added the third bullet there to the locations that we do have one crewed NASA location in space. Everyone recognizes as the International Space Station. Specifically, here we are at the Armstrong Test Facility. We're located in north central Ohio. On the right-hand side, you can see an aerial shot of our campus. The campus is 6,400 acres, roughly 26 square kilometers. It's a large campus managed by NASA in rural Ohio, and it's near Lake Erie. You can see the Lake Erie in the background, and the city of Sandusky at the edge of the water. So to our customers, as Dave Taylor mentioned in the morning, to our customers, we are a spaceflight experimental test facility, for testing spacecraft on the ground to see how they perform in the service environment. For the purposes of this talk today, I want you to think of Armstrong Test Facility as roughly 120 technical and non-technical staff operating about 6 aerospace test facilities. We're trying to do more with less efficiency. We're trying to comply with federal directives to move away from paper and into electronic records. And we're trying to modernize our methods according to best practices, which is a federal reference to use open source software where possible. And my last bullet is that we've been running a MediaWiki platform for a number of years, and it's sort of been exponentially growing in its use at ATF. So now we get into what the entry point of the whole conversation of quality work instructions. So the idea of a quality management system is essential to what we do and the products and services that we provide to our customers. And the first takeaway is that what we're doing in order to guarantee a quality product, what we're not doing is deciding for ourselves what quality is. What we are doing is working with an international standards organization, otherwise known as ISO, and they have developed a generic high-level program for how any organization in any industry can provide and standardize the quality of its output and services. And so they've listed 7 principles of quality management. And for the purposes of today's talk, what I want to focus on are the 2 that I've highlighted in green, one of which is a process approach to quality management, and the other is evidence-based decision-making. And so those 2 dimensions of quality management are going to play a very central role in how we fulfill our quality requirements. So the short answer, or the short statement, is that a quality management system is something that we get from the international standards world, and we have to apply it to our world. Now, this international standard, whether depending on what industry you're in, the medical industry is ISO compliant, manufacturing and healthcare and education, they all have this requirement to be ISO compliant, but each industry has its own unique way of fulfilling the high-level generic requirements. And specifically in the aerospace industry, there's a specific standard called AS9100, and the AS9100 standard, if you comply with that, then you are ISO 9001 compliant, and you're ISO 9001 compliant in a way that all of the aerospace industry partners recognize. So our customers are AS9100 compliant, we strive to be AS9100 compliant, and that means that all of our interfaces will have the same understanding of quality. So when we start to unpack what this quality management system looks like, what we see is that you have high-level requirements that then reveal that we have a process approach to delivering our products and services, and those processes unpack into a collection of procedures and work instructions. And so, as you can see from the arrow on the right-hand side, at the very top of the diagram, you start with high-level abstract goals for quality, and as you move down through process procedure, you get more and more detail into what you're doing, and at the bottom level, you have your detailed work instructions. And again, what we're striving for here is that we want our work instructions to be the engine that provides the data that allows us to do evidence-based decision-making. So an ISO process, the diagram in the bottom right represents a generic ISO process. You have many times the processes span multiple departments within an organization, and they span even outside of the organization. There's something that the customer has to do, and then it comes back into the organization, and maybe it goes out to some kind of an auditing organization. The point is that each row of the ISO process is thought of as like an actor swim lane. And each activity within the actor swim lane is a specific task which is governed by the work instructions. And so each process will have defined inputs, defined tasks within, by well-defined people and well-defined output. And that's how we guarantee, when Dave Taylor was talking about how the shuttle runs on paper, this is sort of the engine of producing all that traceable accountability documentation that allows us to not just claim that, you know, that the output is good, but we can show the evidence that the output is good. So let's do a quick example. So remember that time when Apollo 12 launched and the Saturn V got struck by lightning twice on the ride up? Well, that's an example of an unplanned electromagnetic event in the mission planning. So these are the kinds of episodic things that we don't expect that can happen to a spacecraft during the mission planning. And one of the things that we're going to talk about is how we have a need for showing the customer that should something terrible like this happen, that the people in the systems are going to endure it, and that's the fancy word there is immunity. And so one of the things that we strive to do at Armstrong Test Facility is we provide immunity testing to spacecraft so that when they actually launch, they have evidence that shows that they can survive things like this. But unplanned electromagnetic events are not the only problem. We also have lots of planned electromagnetic activity. And so I've got a couple of diagrams here. I'm not an expert on all of this. This is meant to just make a point. On the left-hand side, what you can see is the green and orange lines represent radio emissions being exchanged between orbiting satellites, ground-based systems, and the International Space Station, and the Space Shuttle, or the Artemis, or the SpaceX Dragon 2 capsule, anything that's trying to rendezvous and dock with the ISS. During the ascent from the launch pad from ground level into low Earth orbit, there's lots of weather tracking, or weather radar, and tracking systems and telemetry systems, and all of that is electromagnetic energy, and all of it has to be understood, and the different systems. And so the middle image is trying to show that the Orion spacecraft is not a simple object. If you remove the outer skin, what you'll find is there's a tremendous amount of what we call avionics. And that's just a fancy word for electronics that flies. So if you take any kind of a computer and you add it to the spacecraft, it becomes avionics. So the spacecraft has lots of avionics. There's lots of avionics on the International Space Station. There's avionics inside the crew module. And all of that needs to be tested. So how do you do that? Well, you come to a facility like the Armstrong Test Facility. You bring your spacecraft and you put it into one of our chambers. The diagram that you see here is an artist's rendering of what the electromagnetic test experience is like. So there aren't truly blue plasma beams in the chamber. It's an artist's rendition of what it would look like by injecting radio energy into a controlled chamber, and then by bombarding the spacecraft with electromagnetic energy, the operators can put it through all of its paces, and we can very carefully determine what the energy, how strong the radio energy can be before you get a system upset. In the industry, what we talk about is this mantra, fly as you test and test as you fly. The idea is that if what the vehicle does within the chamber is a good representation of what the vehicle will do in service. And as you can see, we don't test the entire, the rocket that you would see on the launch pad is not what comes to Armstrong Test Facility. We're only testing the upper stage payloads and upper stage entities. And so these articles that we're testing ultimately have to be then shipped to the launch site and then integrated with a much larger complex system. So the vehicle, before it launches, is assembled, and all of the different parts of the vehicle are managed by different groups and different organizations. Sometimes this company provides the launch system, sometimes this organization provides the payload, and they all have to coordinate on a quality product. And so the people in charge of the Orion space capsule, they have built it and developed it according to AS9100 quality management standards. We test it according to AS9100 quality standards, and the launch service providers, and they all follow an AS9100 quality management system. And it all plays nice. So this is a photograph that was taken around 2020 of the Orion spacecraft in one of our chambers. What you can see is I've put the two green elements of the quality management system, process approach and evidence-based decision-making, to basically emphasize that in order to get the spacecraft tested and delivered to the launch site and integrated into the final vehicle, all of that involves multiple organizations all doing quality in the same way. Just an artist's representation of what the Artemis 1 mission profile was. Back in November of 2022, the spacecraft that I showed you in the previous slide that was in our chamber back in 2020 successfully, for the first time since the Apollo era, that spacecraft successfully launched from Earth. It orbited the moon a number of times and came home safely. And the message from this chart is that the safe, effective, and reliable performance of the Orion spacecraft is largely due to NASA's strict adherence to an ISO 9001 quality management system at every stage of development, testing, integration, and flight operations. So what are these ISO requirements? And so what I'm showing here is an eye chart, and I don't want to read this to you, but what I want to focus on is my personal attempt to summarize what these requirements are saying. So if you were to actually get a copy of AS9100 and you were to look into Section 8, you'd find a section on operational planning and control. You'd find 8.5 talking about service provisioning, which is what we do. And the top box is basically saying that what we have to be able to show our customers is that the work that we did on their spacecraft is work that we planned in advance. We also need to be able to show them that it is work that was done according to that plan. And we also have to be able to show that it was work done by people qualified to do that work. These are all the evidence-based paperwork that we need to be able to show. And then number two is that we also have to be able to keep track of that the way that we record all of the information in item number one is also a well-managed artifact system. Now, we're at a MediaWiki users and developers workshop, and little bells should be going off in your head that MediaWiki can make quick work of all this. What's the problem? Well, that's what I want to talk about. How we're implementing MediaWiki to fulfill these requirements. So as a brief example of what we kind of do here, so we've got a large vacuum chamber that we drop the spacecraft in and do vacuum testing. What you can see is the Dragon 2 capsule on the left. It's being lowered into one of the chambers that we will tour later today. And on the right-hand side is just an expression of the 20-some pages of work instructions that have to be followed very carefully in order to make sure that we don't accidentally drop the spacecraft, or that, you know, after it was located or lowered into the chamber properly, it was lowered in a very planned and controlled way. It didn't experience any unanticipated shocks. The point is that we have tens. You know, this particular example is about a 20-page procedure. If we look at what this process looks like as we stand back, there's a flow diagram at the top that goes from left to right with different steps, tasks in between. And what you can see is this kind of boils down to we develop a work instruction, and it's usually like a document of some kind. And so step one is, in order to do this process, is we print that document out on paper. And then we have to go around and collect signatures the old-fashioned way with pen and ink, and get that procedure authorized to be performed. And then we have to give that piece of paper, usually on a clipboard, to somebody out in the field that does the work. And as they go through each step of every task in that document, they are checking off who did what and when, so that we can make sure that the right people did the right work at the right time. And then at the very end, we have this heavily written on piece of paper, and that has to become a record that we keep, and we have choices, right? We can either keep the paper copy, or we can scan it in and upload it to some electronic repository. This is basically the process that we've been doing, and the problem is twofold. One is that we're being told that paper records are no longer acceptable, that all of our artifacts that should be available for our customers shouldn't be physical, they need to be electronic so that people can audit and get that evidence-based decision-making ability remotely without having to come out and rummage through our file cabinets. And so there's a lot of interest in trying to digitally transform this process. But before we move on to that, we have to look at the pros and cons. So the pros of using paper and pencil in 2025 are that it's really simple, it's very reliable, and it's AS9100 compliant. Okay, those are the pros. Now the cons are, from a knowledge management perspective, so I'll let you read the cons that I've provided here. It's not meant to be a complete list, it's just the first set of cons that came to my mind, but I want to draw attention to the obvious reality that paper makes knowledge management difficult and problematic. And so more and more we find ourselves in a situation where the shortcuts or the convenience that we took in doing the quality work is becoming an encumbrance down the road when we're trying to take credit for that work. So we want to talk a little bit about what knowledge management is. And I don't want to spend too much time, this is very high level, but in a nutshell, for us, knowledge management is about three things: people, processes, and technology. It's about getting the right information to the right people at the right time and helping people create knowledge and share and act upon information. That's the ISO requirement, evidence-based decision-making. Act upon information in ways that will measurably improve the performance of NASA and its partners. That's not my definition, that is NASA's definition of knowledge management. However, when we actually go and try to put this into practice, here's what we find. We take our current process, which is simple, reliable, and AS9100 compliant, and what we find is that these three things, the people, processes, and technology, are separated. They're not closely coupled, they don't interact, except in very primitive ways. So the technology is paper and pen, and the process is some document on some document silo, and the people are out in the field filling things out by hand. And so the problem that this incurs is that the idea of knowledge management is now a fourth thing. So if we said that knowledge management is people, processes, and technology, suddenly knowledge management becomes item number 4. And that's something that has to be done on the back end. And so what we would prefer to do, well, so let me just plant a flag there and I'll come back. So let's say we wanted to optimize this process. And this task just showed up on your desk and you've been told, solve this problem. Well, you might go out and say, what are the industry standard quality management systems out there that I should pick from? Because you as a user are now tasked with finding QMS software. Now, the dial that I'm showing in the graphic is a metaphor. It's my way of saying there is no official grouping of software products out in the commercial world. What you do is when you look out at all of the available commercial off-the-shelf software, what you find is that there's clusters of softwares that do similar functions for similar purposes. And in this specific analogy, I'm saying that, like each piece of software, each product is a star, and the clusters make constellations. And so when you're out looking for software, the constellation that you look at, the set of software products that you would be evaluating, is usually based on the software that you're seeking. And the problem that we have here is that the only people who seek MediaWiki as a solution are the people who are seeking a wiki. And this goes back to my MediaWiki Plus claim, is that one realization that I've had over the past number of years is that with all of these third-party extensions that you guys provide and create, you can allow MediaWiki to save data, structured data within its pages, and with other extensions you can query that data back out, and that allows you to replicate the basic functions of a database platform. And the database platform allows you to implement with other extensions like forms and templating and ways of controlling the way pages render. You can build complete electronic workflows that implement whatever it is that your organization is doing from a process standpoint can be implemented with MediaWiki. And so for that reason, when we look for quality management software, somehow we have to send the message that MediaWiki plus all these extensions is a very adequate QMS software solution. So my message to you now is that ISO requirements plus MediaWiki plus results in integrated knowledge management. So that flag that I planted earlier, we're going to come back to it and say that we've taken the people, the processes, and the technology, and we've tightly coupled them, and we've turned knowledge management not into another fourth activity that has to be done after all the work is done, but we've basically said that the work of doing the work instruction happens within the medium of knowledge management itself, so that the information is always in the right place. It's always available to the right person at the right time. So we take our process that we talked about, and you can see I've X'd out a few of the steps that are no longer necessary in a digitally transformed process, and now we're going to be able to take our work instructions that we have as developed and planned documents, and we're able to spawn instances of them, and we're able to fill them out. Take electronic tablets, Wi-Fi enabled tablets into the field, and perform these work instructions within the MediaWiki environment, and even do the review, the quality check on them, and then ultimately when the work is done, the knowledge management is done. So when the procedure is complete, all of the signatures are in place electronically. The as-run instance of the work instruction is where it needs to be. There is no fourth activity that has to be performed. You just move on to the next task. These are the pros. The pros are it's reliable. It's AS9100 compliant if we implement it correctly. We have identification, traceability, accountability. These are intrinsic features of MediaWiki Core. This is what you get out of the box. The workflows can be defined and managed within the wiki itself. That's our process optimization. And we're able, with the wiki solution to do these work instructions, we're able to enable real-time data for objective decision making. And the data itself is natively integrated with all of the other processes that we have digitally transformed and ontologized. And what this turns into is a very strong and robust single source of truth for the organization performing the work. Now, there are some cons. The cons are that it does require, if we're going to go electronic and have tablets in the field to do the work, we do have to plus up our Wi-Fi coverage around our facilities, which has been a challenge. There are added IT costs. We have to purchase a fleet of tablets and manage them. And then there's time that it takes to retool, to train, to convert our document-based work instructions into wiki-based work instructions. There's an investment there. I will point out that is a non-reoccurring cost, so once you do that work, you get to continue to benefit from it, but there are some cons. In summary, what's been done to date, and I'm not going to read through all the items that I've put there, but I will highlight the ones that have the arrows on the left. So in 2018, we officially established a MediaWiki server. We went from an experimental tinkering system to something that was officially sanctioned for official work. in 2018. And that is largely due to the work that James Montalvo and his team established, and the Flight Operations Directorate at Johnson. So they pioneered the stable, secure MediaWiki platform through a project called Meza, open source project called Meza. We implemented that and adopted it in 2018, and we've been doing that ever since. In 2020, we reached out to Wikibase Solutions, and we pitched to them, or we solicited quotes from a variety of providers, and we went with Wikibase Solutions to do a pilot project to demonstrate the capability of a wiki-based electronic work instruction system that was AS9100 compliant. I will say, though, before I jump to the 2024 bullet, is that we struggled with an unsupported version of MediaWiki. So we had our production wiki server was running not the latest and greatest version of MediaWiki, and so some of the extensions that are vital to doing this electronic work instruction solution, some of these extensions only came out to support MediaWiki 1.35. So we were stuck at 1.34 until we could find the time to pay the technical debt to get ourselves upgraded. We contracted with WikiWorks in 2024. They helped us get updated Meza to 1.39, and so now we're back on a long-term support release of MediaWiki. We get to benefit from all of the latest, greatest improvements of extensions, and here we are in 2024. We migrated our production server. We did the upgrade that I was mentioning, and now we're ready to begin phase 2. So what I'm hoping to be able to do in next year, either myself or one of my colleagues, we will be able to show you a concrete example of the final implementation of these quality work instructions through MediaWiki Plus. So my last chart is basically a return to the beginning of the chart, and the only difference between what you saw up front and what I'm showing now, and I think I need to move this out of the way. And so we are running a paperless, or we're on track to implement paperless, open source work instructions, electronic work instructions that are fully integrated with our knowledge management platform, and which serves as a knowledge graph node editor, which is the low entropy dimension of the work, and all of it is AS9100 compliant. Think. So my message is that quality work instructions are an essential part of NASA's approach to mission success. MediaWiki Plus has what it takes to help NASA comply with AS9100, and for the benefit of all. Thank you. I didn't check my time. I think I'm a little bit over.
Yeah, you started a little late. So.
Okay. Do we have time for questions? Okay. Megan.
Hi. Given all of the downsides of having the paper records, but they still are AS9100 compliant, I'm wondering if there's a new standard being worked on, or if you expect there to be one specifically for electronic quality management systems?
That's a great question, and it actually gets to the heart of what ISO is all about. They go out of their way to not tell you how to meet their requirements. They simply say what you have to do, and how you do it is always a moving target. So the short answer is that the ISO requirements and even the AS9100 requirements are immune from technology changes. So if we roll back, my apologies, if we roll back to the chart that talked about the requirements, if you were to take the time to read the detail, what they care about is, are you controlling the process? Can you identify the people who did the steps? Can you prove to us that the steps were done in the order they were prescribed? So these are all abstract, high-level objectives. And whether you use paper or telepathy or MediaWiki, how you achieve that is left as an exercise to the organization.
So to take a bolded phrase, enabling traceability is like a moving target as what well traceable means with the technology available.
There are norms. There are certainly technology norms. But I would say, and I would be curious if James agrees, that, that the norms are not well suited to the task. And so it's basically the game of trying to fulfill what you have to do with the things that you know how to do, and trying to get people to learn how to do new things, how to meet these requirements in new and more efficient ways, then becomes an organizational task. Thank you. Okay. I'll switch over for you.